My name is Daniela, and today I am going to present about thermodynamics. The topic correspond to me is the first, that it's temperature and amount of heat. But first, we are talking about what is thermodynamics. Okay, thermodynamics is that heat. It's just one of several forms of energy can be explained by a mechanical model. It's today common knowledge, but it's only about 100 years old when the physician Julius Robert Mayer formulated in 1842 his ideas about the energy conservation for the conservation for the conversion of mechanical energy into heat. And he could already give a numerical value for the thermal and energy equivalent. That is a simple way to explain what is thermodynamics. What is thermodynamics? Temperature and amount of heat. Okay, in this first, its definition of the absolute temperature given is more for most practical application of temperature measurement that one has used measuring techniques that are reliable, accurate, and easy to handle. Qualitative information about the temperature can be already obtained with the head sensibility of our body. It's like the touch. Yeah. Our skin has sensors in this way on our skin, and that inform use whether it's body cold or not. Okay, temperature measurements, thermometer, and temperature scales. The geometrical dimension of solid, liquid, or gaseous bodies, which generally increase with the temperature. The electrical resistance of a body changes with the temperature T, and the electrical contact potential difference between two different metals in contact changes with temperature. So, the radiation power emitted by a hot body increases with T and can be used for the measurement of the temperature of remote bodies, such as stars. Devices for the measurement of temperature are called thermometers. For daily practice, the expansion of liquids are generally used a liquid thermometer or the change of the contact voltage thermo elements. For the quantitative specification of a temperature, numerical values for fixed temperatures have to be defined that can be accurately reproduced under readily realizable external conditions. We have the Celsius scale, the Fahrenheit scale, the absolute temperature scale, and the accuracy of thermometers. The Celsius scale is by the astronomer Anders Celsius, proposed in 1742 to use the explanation of a mercury column for the measurement of the temperature. It's the common thermometer. The Fahrenheit scale is proposed by Daniel Gabriel Fahrenheit, is still used in the USA, and it defines a fixed point, the melting point of a defined as water, ammonia, chloride, and solution. And the absolute temperature scale, it's the absolute temperature scale needs only one fixed point, which is the triple point of water. It is measured with gas thermometer. And accuracy of the thermometers, the temperature scale of liquid thermometers depends on the choice of the liquid and also of the glass of the thermometer capillary, because not only the liquid but also the glasses expand with rising temperature. The next one is thermal expansion of liquids and solids. This is the equation of liquids and solids. The length L of a rod changes with temperature. Experiment shows that the relative length change within a restricted temperature range is approximately proportional to the temperature change. This is the question, and it's complete compiles a numerical values for A for some materials. One can see that for most material A is positive and can be measured with the device show, and a tube made of the material to be inspected is each clamping of end A. The next one is thermal expansion of gases and gas thermometer. Experiments showed that the volume for ideal gases increases at constant pressure proportional to the temperature. This say that the law of Gay-Lussac, the gas thermometer utilizes this pressure dependence for the measurement of the temperatures. The volume B is connected with a U-shaped tube filled with mercury. The height of the mercury in the left side of the U-tube can be changed by up and down lifting of the right side, which is connected with the left side by a flexible tube. And the last one, absolute temperature scale. We will now discuss the relation between Celsius scale and the absolute temperature scale, which also called after creator Lord Kelvin. Kelvin scale or thermodynamical temperature scale is the absolute temperature was used in the general gas equation. Relative pressure P, particle number N in the gas volume B with T. The absolute temperature T was defined by this equation that is in here, by this equation, and which based on the result by kinetic gas theory. The general gas equation states for that constant pressure and temperature the gas volume has defined value which the same for all ideal gases independent of the specific heat. And this is all. Thanks.